All right. The first questions are going to deal with linear. So the stuff that you might have seen all the way back in middle school, going into grade 9 and a little bit more into grade 10. But let's go through it slowly. If you have questions, ask. It is going to be super important for us the entire semester to just clarify. If there is just one thing like, how did you go from there to there? That's fine. Ask away, please. If it's like, I don't understand anything, what does that word mean? If you need to, ask away. I may not be able to answer perfectly if you do that on a test or a quiz, because you're supposed to study. But during class, like that's when you're supposed to just, like bombard me with questions. So I hope you take that advantage of that. What is true about the linear relation y equals 2x? Let's get a little bit closer. Okay, let's go. What's the shape of this graph? So the nature of this question is you take a look at this and see if you remember that or that looks similar to another type of equation you've learned before. And then you make a judgment call on what the shape might be. I'll give you a hint. Graph could be a straight line. The graph could be a slanted line. The graph could be a parabolic line. And I don't think you've learned anything other than this up to grade 10. So you have a 33% chance just from guessing. What shape is y equals 2x minus 1? What type of shape is it? Horizontal, slanted, or curved? Take a guess if you don't know. Brennan? Slanted, absolutely. This is actually in the form of y equals mx plus b. Does that sound familiar to you? Yeah, we're actually going to change that up. Instead of trying to get you to pair it with mx plus b, because that's a little annoying, I'm actually going to, when we get to Monday, or Tuesday rather, talk about what exponent do you see on the x. That alone tells you everything about the shape. Yes? Pardon? We don't have class on Monday? No, sorry. Monday's class, I forgot it was something else. Tuesday class, we'll talk specifically about the exponent things, okay? So what's the shape of the graph? It's going to be straight line, not a parabola, not a hump like a mountain, okay? What is the slope? Now that you know this is mx plus b, which number is the slope? And you have two choices. Again, these are like multiple choice test taking skills, right? Trying to narrow it down to 50-50 chance. You have two choices, 2 or -5. Maria? Here. How do you know that? It's in front of the x, sure. We are matching the letters M or B, and the M happens to be what we call the slope. Well, you'll see this is also corresponds to what we multiply by, how much larger we get every step of the way, but whatever you want to call it, that's fine. What's the slope of a perpendicular line? Ooh, my grade 9s hated this, I remember. So there is a special something that happens to the slope when we're looking at perfect 90 degrees, perfect perpendiculars. I see Maria's hand. Anyone know? Max, you want to give it a shot? It flips, right? Something about the flipping. So what we call a reciprocal. There's something else that happens to it. Cameron? It is well, yes, when we flip it, it is going to become a fraction. So the 2 is actually the same as saying 2 over 1. So the reciprocal is 1 over 2. But it's not just 1 over 2 when we do a perpendicular. It is it's a negative reciprocal. And that was sort of something that you were told to memorize probably during COVID because there wasn't enough time to explain. But it actually makes sense. Very quickly. If I have a graph that goes like this, it's going towards the positive side. It's just getting bigger and bigger and bigger and bigger. If I draw a perpendicular line, is it getting bigger or is it getting smaller? Right? It's going lower, right? It's going lower. It's the slope is actually in the negative direction. So it sort of makes sense that a negative does appear. I'm not going to go too deep into like the math behind it, but it's something that we discover like, oh, it always happens. Negative reciprocal, memorize, negative reciprocal, memorize, negative reciprocal. Grade 9. Okay, let's keep moving. Which ordered pair, in other words, if you're not sure what that means, an ordered pair is basically a point, an XY point. Which XY exists on the line y equals 2x minus 1. So there's two ways you can do it. You can try to see, oh, maybe the -5 has something to do with it, or you can actually plug in. What if x is a 0, what's my y? If x is a 0, what's my y? If x is a 5, what's my y? If x is a -5, what's my y? You're basically checking every single x, which is annoying. But sometimes you have to. So let's pretend you're going to go through all that work. If x is a 0, 2 times 0 is 0. Thank you, whoever said that. 2 times 0 is a 0. 0 minus 5, -5. So when x is a 0, my answer is -5. This is my answer. Okay. Which of the following graph, so use the following graph for question 2. Question 2 asks, which line is a negative slope? So here's my hint up there. Take a look at every single one of them. Charlie? Yeah. I thought that was a hand, but. Pardon? Or negative slope. Those are actually very, very special lines. Okay. So the answer is something else, but consider this. If you want to have a negative slope, you could think of negative slope as a downward or a negative staircase. A negative slope is like if I go to the right by 1, I go down by something. I go to the right by 1, I go down by something. I go down. This is what we call a negative slope. So out of all of these lines, which one sort of represents going down the steps? See it? Good. It would be PQ, absolutely, and it would be GH. So the answer would be PQ and GH. That's B. So as you're seeing, up until now, probably when you're calculating slope, you've been always using numbers and trying to do all these calculations. But again, as you see, you're trying to communicate information using numbers. That's all math really is. It is a language. And I hope that you'll continue to try looking at it in that way so that you can better absorb the idea. Okay. Let's see. All right. Just to go back to C, D, and EF. These two are very, very interesting. It has nothing to do with the questions, but I want to cover it anyways. C, D. If we were walking along a road that looks like this, am I going up or am I going down? Neither. So is a slope positive or is a slope negative? Neither. In fact, the slope for this one, I'm going to call it M for slope. The slope for a horizontal line is a 0. It's not going up or down. But what if I was walking? You have to be creative here. What if I was walking on a road that was vertical? Am I walking? What would that represent in real life? If I was traveling along a road like this, what am I actually doing? You're like playing Spider-Man, right? You're either climbing up a wall or you're falling. In this particular case, the slope is infinite. There's no actual plus or minus. It's just a cliff. And so for these vertical lines, the slope, we actually say you can't put a number on it. You can't define it. You can also technically say that the slope is infinity because it's infinitely going up. There's multiple ways you can talk about, communicate this idea. Okay? Yes, Ellie? CD? CD is not undefined because we're actually not going up or down. Whereas here, from E to F, clearly, there is a difference in height, right? But how high? Like, does it have to be just from here? Like, it's literally going up forever. And so you can't put a number on it. And that's why we have no choice but to call it either infinite or that's it. That's it. So it's just communication stuff, okay? And what's interesting is if we start plugging numbers into it, you get the same explanation. I'm not gonna get you to do the calculations. Let's do a different one though. Number 3. Calculate the slope of a line passing through 0, 5 and -2, -3. Show your work. So you're gonna have to reach back to your grade 9 skills. Let's say instead of asking you visually, I actually want to calculate what the slope of PQ or what the slope of GH, the actual number might be. Well, there's a formula. All we need are 2 ordered pairs. And what's an ordered pair again? Someone else? What's an ordered pair? Yeah, I just need an XY coordinate pair. I need 2 of them. I give you 2. Up here. One of them is going to be 0, 5. One of them is going to be -3. I gave you 0, 5 first. So let's call this the first X, and we will call that the first Y. I gave this point next. So let's call that the second X, and let's call that the second Y. And you just plug it in. Slope is going to be the second Y over the second X minus, and then what's the first Y? The first Y is 5. And then the first X is a 0. So this is -3 minus 5 over -2. I should do this here. Ooh. Sage? It's actually -8 over -2. And we're going to simplify that further. So how about I do this? It's -8. So -3 minus 5 is -8. And then -2 is still there. So it's -8 divided by -2. Some people don't like fractions. Some people just plug it into their calculators. They do a whole bunch of things. Negative divided by a negative will be a positive. 8 divided by 2, 4. The slope is 4. It's a pretty high slope. All right, here we go. We'll finish the first page, maybe take a 5-minute break, and then we'll come back. Here's a communication question. The Y-intercept. Think about it graphically, okay? The Y-intercept. It's on a specific part of a Cartesian graph. Will the X be a 0 or the Y be a 0 if we are talking about the Y-intercept? Hands up. While I do attendance for Micah. I think he came in like 30 maybe. Yeah, sound smart, close enough? All right. What do you think? Oh, Brendan.
Yeah.
It would be. How do you know that? Did you memorize it?
Well, because it's on the Y. On the Y line.
Yeah, it's on the Y line or the Y axis, absolutely. So visually speaking, I think people like the visual part. A Y-intercept means there's a point. Let's pretend there's a line here, right? The Y-intercept means this line, I'll highlight it with pink, right there, is cutting through or intersecting the Y-axis right here. Well, the Y value, it could be it's a positive Y value. Look at the height, but clearly the X value is a 0. Anywhere on this point on the graph, the X is always going to be a 0. Okay? And we can use that to our advantage when we do some math. But anyways, algebra, I'm going to do number 5 and 6 alone because it asks us to isolate the Y, doing some rearranging here. And then I'm going to plug in a -2 using the answer I get from number 5. So just a quick show of hands. I want to see how people have been doing their math. How many people here have simply sort of, when you're doing algebra, you're like, oh, that's a -6. Bring the 6 to the other side. Who tells themselves that when they do the algebra? Just a couple of people. For the people who didn't put their hand up, how do you do algebra? Can you communicate with us or tell the class what you think in your head? Yes. It will turn into some kind of y equals mx plus b. But so the question is, let's say here at -6, what is actually happening? For those of you who don't do what I asked just now, when you are bringing it to the other side, quote unquote, how are you actually doing this mathematically? Does anyone know? What's happening to the numbers? What do you do to the numbers? Leanne? It is going, but why is it changing? Is it magic? Like, did you have to memorize negative becomes positive? What's happening? Because math is not magic. Remember, you're communicating something. What? Correct? No. That's right. And a lot of math teachers, it's not necessarily your fault. Elementary specifically, a lot of teachers are like, oh, it's a -6, just put it to the other side, get rid of it. It's not necessarily true. That's what it looks like. But that can create a lot of misconceptions. So I'm going to ask everyone here to try to adopt the method where if you see something, do the exact opposite. Remember, we have an equal sign, right? Which means the left side and the right side of that have to be perfectly balanced, right? It's sort of like you and like maybe you have a baby sibling. Like I got my 3-year-old that fights a lot with my 1-year-old, right? And the 1-year-old has to do everything the 3-year-old is doing right now, right? The 3-year-old is like playing, like literally climbing the computer to reach like one of the toys up on top of the piano, right? The 1-year-old is climbing too. Okay, I don't know how many bumps she has on her head right now because she's doing all the dangerous things that 3-year-old is doing, but you get the point. You have to do everything together. One person gets a cookie, other person gets a cookie. One person gets $1 to go to the convenience store to buy a candy or whatever. The other one has to get $1 to go to the convenience store to buy a candy. They have to be equal. And so, taking that stupid example that I just gave you and putting it into math, if you want to get rid of a -6, well, wouldn't it make sense to add a 6 so that -6 and +6 become? But if you do it to one side, you must do it to the other side. Okay? Now, it's annoying because up until now, you just did one step. Oh, -6, just bring it to the other side. when you really do the math, you're doing two steps. You're doing, okay, how do I get rid of a -6? You add a 6. But if I add one side, I got to add two. It's two steps. But once you do it again and again and again and again and again, it will become one step. You'll do it so quickly because it's natural to you. Let's continue. So this becomes x minus 2y equals a +6. My goal is to get y all alone. So put your finger there. What's next to the y? Next. How do I get rid of a +x? Go ahead. I subtract I don't know what the x is. I really don't. It could be 1,000,000. It could be 1. It could be -25. I don't know. I'm going to get rid of it here, which means I have to also get rid of it there. This becomes -2y equals 6 minus x. Now, I could switch the locations later, but I'm just going to keep it there for now. Now, I want y all alone. The -2 right now, please be aware, the -2 is actually multiplying with the y. It's a multiplication. What's the opposite of a multiplication? Division. So you have to divide all of this. I'm going to divide all of this by a -2. And if you do it to one side, you got to do it to the other. So all of this is going to be divided by a -2. What's the final answer? Y is equal to 6 minus x divided by -2. Some people might not like what I wrote. Instead, maybe I give you an alternative. Write what makes you happy. I'll give you another option. Y is equal to 6 divided by -2 and minus x divided by -2. You could do things separately, right? You know how I said everything has to be divided by -2? So you take the 6 separately, divide it by -2. You take a -x separately, divide it by a -2. And if you do that, this becomes what? 6 divided by -2? -3. And -x divided by a -2, that's going to be a positive x over 2. You're not necessarily wrong no matter what you do. However, between this one and x over 2 minus 3, which one looks cleaner? Between these two, which one looks cleaner? That's why from when you were at a young age, people kept on saying, simplify, simplify, reduce, reduce, make it look nicer, simplify, simplify. It's a mathematical convention to try to simplify as much as you can. Okay, so we'll continue to work through it, but as we get through the semester, maybe even by the end of this month, I hope that you'll be able to remind yourself that it's best to write it in a simple way, like in a simpler way. Okay. So, number 6, take this equation. What is the value of y if the value of x is -2? What does that mean? Forget the math. What is the question asking me to do? No? No? Are you sure? All right. Let's break it down. Just because I caught your eyeballs, all right? Where do you where's the x? Carter? At the start. No, like, look at this. Where's the x? Above the 2. It's the numerator, it's the denominator. Great. What is the x? -2. What do you think it's asking me to do? Here's the x, but the x is -2. Right? Yeah. Well, it is what's the value of y. So I want to know what this is. They tell you that x has to be -0. So what they're actually, well, all they're asking is find y if instead of an x, you plug in a -2. That's what this means. Yes.
Oh, yeah, let's ask if I can see if you can answer.
Oh, yeah, go ahead.
Y is -5. Because you can add, since the x is -2, if you add 2 to both sides of the equal sign, it becomes 4, and you have to add 6 to both sides, to get -6, then it becomes 10, so it's -2y equals 10. And then. if
Oh,
divide by
are you
2,
plugging in directly in here?
Yeah, but what I was doing is, oh, no, okay, sorry, I did this wrong.
Well, we'll solve it this way, because whether you use this equation or whether you use this equation, you should get the same answer. Because take a look, this equation, after all of this math, does equal this. It does.
I'll just say, I thought -5 is fine.
Okay, well,
Subtract that.
we gotta try it again. Try it out, try it out. -2 divided by a 2, you can use your calculator or you can use mental math. It's going to become, confirm with me if you need your calculator. And if you subtract it, this is actually -4. So let's use our original equation to confirm. Okay, shall we? Well, yes, it's the exact same equation. No, wait. Oh, it's equal to 2. Yeah, I'm wrong. That's my bad. I legitimately thought in my baby brain. Yeah, no, you know what? Let's try it. Let's try it. No, it's my bad. It's my bad. And this mistake is all recorded on YouTube. Oh yeah. You're right. Let's try it. It's a completely different equation because it's not equal to a 0. It's equal to 2. All right, here we go. So x minus 2y minus 6 equals 2. Carter, help me out. No. It's the same question. It's the same question, but with a different equation. All right, where's the x? Carter, come on. I'm going to ask you the same stuff. Where's the x? What is it supposed to equal? So just plug it in. You see there's a repeat of what we were doing. That's all it's asking. And now let's simplify. So I see a -2 here. I see a -6 here. Let's get rid of that first so that we can get the y all alone. I'm going to add a 2 on the left side. I'm going to add a 6 on the left side, which means I have to add a 2 and add a 6 on the right side. Right? So I have -2y. So how about I highlight this? Maybe I highlight it in blue to show that. So this becomes 0. That becomes a 0, leaving me with -2y equals 2 plus 2 plus 6, 10. And so it looks like Cameron got it. -2 is being multiplied by what? Maria? Yep. Mm-hmm.
Is it wrong to divide everything by -2?
It is not wrong.
Okay.
It's simply your choice.
It's just,
You decided to get y all alone. Is that correct?
yeah.
That's totally okay. You simply rearranged it to get y all alone. It's not a bad habit to have.
It's more right to add out the other numbers.
More right. I'm going to say if you do it this way, you will save time because it didn't ask you to rearrange. It just wanted to find what the y value is. But it's not that it's wrong. There are some cases where you do have to simplify before you can get anywhere. So it will probably tell you to rearrange first and then solve.
So the question is, right?
If you had to rearrange it, what you did was correct because you got the y all alone. Yep, Charlie. Why did I not add anything to? Oh, right now, my goal was to get the term, that number that has the y value in it all alone. So you see how it's all alone on the left side of the equal sign? That was my goal. Once I do that, I can start piecing away the other parts and getting the y value all along. Think about it like this is a terrible example. Think about it like a fruit basket, all right? We got a fruit basket, and right in the center of it is the orange that you want. But around it is the apple, is the banana, is the grapefruit, is a bunch of other things. So what you got to do? Gotta take that stuff out. And once you finally get that orange, you can start peeling it off and get to the meat of it, right? Terrible analogy, but I hope you get what I'm saying. Yes, Carter? Yes, you may. Nice, thank you. All right, so now that we have -2 being multiplied with the y, remember it's multiplication. Divide both sides by. Oh, it's a rough morning, man. I told you. Oh, I handled these things today. More coffee. All right, so this becomes -2. Any number divided by itself, right? Any number divided by itself becomes a 1. So y is equal to -5. There it is. Okay. All right. Let me take a look at the back here. I'm not too worried because we will get a chance to talk more about quadratics again. We will get a chance to do more expanding again. We will definitely do more factoring again. I wonder how much SOHCAHTOA, how much trigonometry you people remember. Maybe it requires everyone to have a calculator. Who has a calculator that could do trig today? All right, everyone. You have, I'll tell you right now, everyone who doesn't have a calculator, you have until, today's February, March. I'm gonna say you have until March to get a calculator that can do sine, cosine, tangent. Until then, I highly recommend if you have an Android, to get this app, Scientific Calculator. It's my favorite one. There's a lot of calculator apps out there, but the reason why I like this one is because, as I said before, there's an answer button. Okay, it's my favorite one. And it's very useful. It's got your sine, cosine, tangent in there. It shows a lot of numbers. It shows all of that. And yes, there's an ad, but like, who cares about the free Whopper? Close. Okay. It shows a lot of digits, but we don't even need all those digits. You can always round. I'm just saying that it is very, very necessary to have a calculator that can do sine, cosine, and tangent. Okay, please get one by March. We won't need one, but you need a calculator soon anyway, so get it sooner than that. We're gonna cut this class a little short, the lesson short, so you can get a bit of a breather for, I guess, 10 minutes. What I would like, if you are a bit more familiar with quadratic, see if you can get this. I will post the answers on the back as well as online, clean versions for you to check. And of course, stuff that you might find familiar with trig, sine, cosine, and tangent. Any questions? No? So then, let me write out your homework. Right, your homework. About me quiz. Please do it, which means you have to join Google Classroom. Number 2 would be do back page of what I'm going to call prerequisite skills sheets. Okay, the answer key will be online and in class. Yes, absolutely. Write your name. And let me, I guess I can stop recording, huh? As the class moves, in the beginning of class, I am going to try to show as many of these